morning, Helsinki. It's a pleasure to be here, and thank you, Jona, for the great introduction. I have the pleasure to talk to you about application building tools, especially what we did in the past years. Actually, for over 10 years, we've been developing a platform. Now, before I start actually walking you through the tool set that we have, let's recap, what are the drivers for smart cities? And actually, it applies for the industry as well. So you have actually three drivers. So the first one is being cost. So how can you reduce cost? How can you do things more efficiently? Like, for example, you want to cut the grass more efficiently. You do video analytics maybe to detect that grass is growing. You do optimization of logistic fleets. You do the trash bin collection more efficiently. So those are examples for cost. Now, the second driver is, of course, revenue. So how can you do more sales? I think from a city perspective, of course, that means that you are dealing with utilizing the public space more efficiently, but also, for example, saying that you utilize the capacity more efficiently of, for example, parking places and so on. So, and the third one, a very, very important driver for smart cities is health and safety. So obviously, like Helsinki, Finland in general is considered one of the smartest or greenest city in the world. So that's why a lot of Chinese are flying here and taking a look at how can they improve from the lessons learned over here. But obviously health and safety from emissions, from an environmental aspect is very important. So for those of you who don't know where I'm from a company called Wapice. Wapice has been established in 1999. We're over 340 software and electronics experts, so we're a technology company. We have 10 offices here in Finland, Helsinki among others. Vaasa is our headquarter, a huge location in Tampere. We won the National Entrepreneur of the Year award last year, and we have been growing successfully all over the years, mainly because we are a reliant partner to a lot of industrial companies. But as mentioned, the same scope applies. So what we have is an Internet of Things office suite. So application tools for dashboard designs, interface designs, reports, data flows, and so on, in one package, so you can very easily build applications. But before we go there, let's talk a bit about reference cases. I think that makes it always a bit more credible when we talk about what we have done in the past in that area. So the first thing I want to mention as an idea, where we work in which domain, in which space, is like we have a product that is IoT Ticket. It's an Internet of Things platform, an Internet of Things application development suite, and you can deploy that basically anywhere. So it runs in our cloud, it runs in Amazon, it runs in Azure, in Google platform, and so on. So it's a cloud-native application, big data enabled, analytics enabled, so fully scales. We have a lot of reference cases basically from smart environment, smart energy, manufacturing, logistics, but obviously here in that context we're talking about smart cities. Now, if you start talking about smart cities, obviously a lot of buildings are in cities. So what can you do there? It's energy optimization, lighting control, personal tracking, and so forth. Here we actually have our smart building management tool. So actually you can design these buildings in the application and then monitor the information from that, optimize the people flow, optimize the efficiency of that along all the areas. Another case actually is like when you talk about a lot of buildings, there's a trend towards microgrids. So when you think about a prosumer, so you have your Tesla at home, you have your car that has the battery, you have an electronic storage system in the future, but you're also having a solar power plant on top of the building, or a wind farm, for example, or parabolic mirrors that are utilizing to produce actually energy, heat, and then you try to sell that off. So microgrids, and then actually when you have several of them, you can transform them into virtual power plants to actually sell the electricity. So you're becoming independent islands, basically, inside a city. So this is a case where we are actively working on. Another one is demand and response. So imagine like you have a lot of huge shopping centers, huge shopping malls. So we basically, the platform is utilized to monitor the energy production information and then give control recommendations to those big shopping centers. So this is utilizing then the demand that is available or that is needed in the building, and then the power plant can give the response to optimize basically the consumption in the air conditioning heating, for example. Another case, it looks very similar, but it's actually a different one. So we're talking about actually trading. So we're connected, for example, to Nord Pool Spot, so the energy trading system here in the Nordic countries, and then you can basically automatically buy and sell electricity. So very similar to this smart microgrid case, virtual power plant case. And the interesting thing is you can get all the reports out, and it's very easy actually to make these logic without any programming. So if we continue on references, so we heard about digital twins. Yes, we have done that also. Danfoss is a reference customer for us. Obviously, it's backup, restore, prevention of downtime, a lot of predictive, preventive maintenance in that area. Caverion is a reference there as well when we talk about a lot of the industrial facilities, but also buildings. And then a lot of things in the energy domain. So when we look at the big power plants here, for example, they run with local SCADA automation systems, but then they are all connected towards the IoT platform where you can easily build applications. Interestingly, when we talk about the volume that goes through our system, so we have over 3 million assets connected. So an asset can be a power plant, and then that gives you the scope, the domain of what we're working in. If you think about, just to give you an example, is when we talk about IoT, a lot of times Kone is mentioned. Kone has a global installed base of 1.1 million elevators and escalators. We have here, as said, over 3 million assets connected. Those 3 million assets actually produce over 75 billion records per hour. So we're really talking about big data. And of course, then this information is utilized to give energy optimization information, electricity need forecast information, and so on. Now, that were the kind of like case stories from the back pocket. We, of course, have this tool suite that is utilized to build these applications. Now, that tool suite actually covers a lot of different areas. So obviously, in a city, you have a lot of different vendors producing the data sources, the data inputs. You have, for example, LoRa, long-range communication. We're a platform partner, for example, for Digita. Digita has about 95% coverage for industrial areas in Finland. And that is actually fairly interesting from a perspective that you can actually deploy a LoRa sensor that is powered by battery, lasts 10 years, and you measure temperature, humidity, for example, or a trash bin. So a lot of different application areas possible. And as said, it also integrates very nicely into different platforms, so from Amazon Web Services, Google, and so on. Now, the main thing here is like you can manage an unlimited amount of assets, an unlimited amount of enterprises, and so forth. And then you can build the applications. You can not just utilize that for monitoring, but you can also do the control, actually, towards the assets, so that you do corrective actions. Over here, we can actually see a video. So all you need is a web browser. You can see, for example, like here, pumps, sewage systems, CPH plants, electricity networks that you can monitor, you can control, you can do the condition monitoring of different assets. So everything actually available just utilizing a web browser. And the nice thing actually is like you cannot just monitor, view this information, but you can also build these applications just utilizing a web browser. Now here we see actually like a flood monitoring and prevention system. You can do the dashboards, the reports, you can track mobile assets, buses. Obviously, you can do a lot of scenarios there that you can say, okay, well, if the bus is driving, predict when it's arriving and optimize the routes accordingly. Obviously, everything needs to be analytics enabled. You need to do a lot of machine learning, a lot of utilizing the information that is available. Obviously, big data is not fast data, so we worked a lot in the past 10 years to make big data really fast data, and utilizing that then for recommendations to build, for example, dashboards. Now, a dashboard you only need to build once. So over here you see the example how you build a dashboard with IoT Ticket. So you just go in the web browser, type in you want to create a new dashboard, and then you actually have a toolbar or toolbox. You just drag and drop the different elements onto a canvas, and then you can start building. You can also attach like a lot of different KPI indicators, for example, like gauges, charts, trends, FFT information. You can also embed 3D objects and actually also dialogues and do the interactions. So for example, that you hit a button and then something happens. Now, all of that is actually nice. You can build nice user interfaces, but you need to make some logic in the background. So we have a data flow editor that then is utilized to actually create the logic without any programming. So you just connect the information together. With that, you can, for example, say, okay, well, if the temperature increases by 5%, give me an alarm, send out a service technician, and optimize the procedure along the way. Now, over here, we see another example of the dashboard building. So obviously, it works across different domains, different fields. So from harbors to buildings to fleet logistics systems. And it's really, really easy to build these type of dashboards. Now, you build them once, and then you can roll them out to the fleet and basically utilize the information. On top of that, you can also utilize 3D components. So for example, like if you have a bus or a truck, you can actually put that in. You can create the logic, for example, that you say, okay, I want to have some predictive monitoring of a solution. So for example, let's say, okay, tire pressure is a problem. So send the truck back into the repair workshop. So all of that is actually possible looking at the digital twin in real time. Now, these dashboards are utilized, of course, for real-time monitoring. So real-time means that I need to take a corrective action. I want to see the current status. I think we heard a lot about dashboards today. However, one of the really crucial functions that we're having in here as well is reporting. So reporting means like it's kind of like Word, but everything is big data enabled, and it's actually building the report along the way when you want to monitor your assets, your building, your part of town, your region. And again, it's very easy to build these type of reports and create the logic then with the embedded data flow editor. So if somebody asks me, how disruptive are we in our field? Actually, my answer is that we make software development obsolete. So in a way that we actually provide the tools to people who work on the front line, who actually work in the field, who work with buildings, with cities, and those tools can be easily utilized to build really advanced IoT applications that then enable cost saving, creating additional revenue streams, and improve health and safety aspects. To give you a quick highlight, kind of again like a recap of the features. So it's basically the web-enabled dashboard building. So not just the monitoring, but also the control part, the data flow, logic creation in the background. Then we have the report building, the alarms and events. So everything you would expect from a an IoT platform or an IoT application tool development platform. You can do the 3D support, the digital twins. We're actually also working on the integration towards HoloLens so that you can, for example, walk through a town and then utilize augmented reality to get additional information. As I mentioned already, analytics, of course, needed when working with big data. Here you see another case for augmented reality. That is basically when you utilize a mobile phone, a lot of sensors are involved. And then over here, we can see our mobile application development tool. Actually, you just, again, need a web browser. And then you can, by drag and drop, create really big data analytics-enabled applications that can be rolled out in no time. Obviously, connectivity, edge processing, is very important. I'm not going to talk too much about that. On the left-hand side, you can see a whole platform overview. You need a lot of different protocols. We speak over 200 protocols. We have own electronics. We work with third-party vendors that have devices. We're also like cloud deployment partner, as mentioned, for Digita, also for Libelium, for example. Libelium is a Spanish company and also considered as one of the companies that drive the smart city revolution quite a bit. They do a lot of these LoRa devices that are out there. And of course, you need to have a lot of ecosystem integration. So we're trying to be very open with the data. You can control it, who can actually insert data, who can send data, but also who can consume that. And actually, you can also like shift that to other systems then through some APIs. Here you can see a couple of more dashboards that are built with IoT Ticket. However, I wanted to also share some nice stories from our innovation group. And the first thing I want to show you here is it's actually a mixed reality, so a HoloLens, and then you're utilizing a mobile phone actually to control real assets. So, and everything is basically going through the IoT platform. As mentioned, we have the 3D support on the web browser, but now we're shifting that also to the real-world experience. And then another example is when you actually talk about the real digital twin simulation, actually, like, for example, you have in Singapore. In Singapore, they build actually like a 3D model of the city and simulate the airflow through that because it smells if you don't build the buildings in the right positions. So all of that is basically possible. Here we work with another company, Visual Components, together, but it's very easy basically to create these type of applications to simulate that and then actually transform that into a real world environment. With that, I would like to thank you and convey the last message. That's really easy. The tools are there, and it's just no limitations whatsoever. Basically, the limitations are your ideas, your forward thinking that enables really a smart city of the future. And then you can utilize a platform like ours to build these applications on top of. Thank you.